Hi, in this video I'm going to do 3D scanner test using all this 3D scanner. Scan this without using the spray. I want to show how well each 3D scanner can scan this part. It's a common part that you will find in the automotive plastic part. It's either black, featureless, and contains a lot of deep pocket and thin shell. So there are 4 types of the 3D scanners on this table. These are the laser 3D scanner, one from the Revopoint, it's the Metro X, 2 from Creality, Sermoon S1, and the Laptor. Usually the laser 3D scanner will perform the best for this featureless part because it's designed to work with the markers, so it will track with a higher precision and give a very clean and sharp result. But they are the most expensive 3D scanner. These 3 are the infrared scanner, starting with the Ferret. This is the first 3D scanner from Creality that can scan the black object without using the spray. I think they launched it 2 or 3 years ago. Next to that will be the Otter. The Otter is also the infrared scanner, and this one is the Otter Lite. The infrared scanner is mainly designed for tracking with the geometry. They all can work with the markers, but not as good as the laser scanner. I show you in this example, you will clearly see the difference between the laser scanner tracking and the infrared tracking with the marker. Okay, the third type is the structure light 3D scanner. This one is from 3 Mega Pros Moose, and this one is the Seal. This scanner is designed for geometry tracking, similar to the infrared scanner, but it will project the structure light in a small pattern. This kind of scanner will track slower than the Creality infrared, but it will give higher precision. It scans about 10 to 15 frames per second, while the Creality infrared can scan up to 30 frames per second. It's not very good at the high contrast surface. If you have a white and black color in one object, it will have a difficulty to scan. So you need to reduce the contrast to be able to scan by using the spray. But if the object is purely black color like this can scan very easy. The Seal and the Moose, the tracking performance is exactly the same. It's that the Seal has a smaller capture range, so it's better for using with a smaller object. And this one has a larger capture range. Different number 2 is a resolution. This Moose has a resolution of 0.2 millimeter. This one is 0.15 millimeter for the Seal. So it will have the similar output as the Otter in a small mode, because the Otter in a small mode has 0.15 millimeter resolution. But for the Moose, it has 0.2 millimeter resolution, so it has the same resolution as the Otter in a medium mode. The last one will be from Matter and Form. This is a structure light 3D scanner. It requires no markers. If you can place it on the turntable, it will definitely track, and it's very easy to use. Come with the 13 megapixels camera, so it gives a higher resolution than the Laptor when you're scanning a smaller object. I tested with the latest firmware update. It can scan the black object very well now. Before that, when scanning a black object, it will give more rough surface from the exposure. Now I can increase and decrease the brightness of the projector, and it scans the black object without a spray much better than before. Let's see which one will give you the best result for reverse engineering. I will also check the accuracy, 20.15. So I will make 2 scans for each scanner. One is the bottom and one is the top, and then I will merge them together. Okay, start with the Laptor Pro in the 7-line blue laser mode. So you will get the same result as the Laptor original. Okay, so I'm going to start with the import global marker. I'm going to use 0.15 millimeter for the resolution because this part is quite small. Okay, so we use the automatic exposure for scanning this. I would like to add something. For the laser scanner, you have two exposure, one for the laser and one for the marker. So you can adjust both exposure. But for the Creality laser scanner, the automatic exposure works quite well. Infrared scanner has only one exposure. You cannot adjust the marker and the surface exposure independently. So if you are using the lower resolution, like 0.2, 0.3, it's going to capture faster. This object has embossed text, and I want to compare the resolution. So I use 0.15. And with the Laptors, you can lean. The leaning angle of the Laptor is quite low. See here? I almost lean it parallel to the turntable. So it can capture the side of the object quite well when using with this turntable. So if you have more surface on the side capture, it will merge more accurate. Okay, I'm going to move to the new scan. Flip this over. So this is the same. If you are using the Laptor original, it's going to give you the same scanning experience with this Laptor Pro. You can see that the gap between the ribs is not captured. It's captured slower. Let's see if it can reach the bottom. So we have a pocket here. It cannot reach the bottom. The 7 line from the Laptors. So the bottom will be left open. So one side of the wall is blocking the projection, so it cannot get into the deep pocket. So I think that's the best it can do. So I'm going to fuse both of the point cloud using 0.15mm for the resolution. Okay, let's merge them together. So I'm going to mesh this one, 1.9 million. Okay, this is the mesh result from the Laptor. Okay, there's a point cloud from the Laptor scan into a thin section. Okay, about 1mm. And I'm going to measure the dimension for the accuracy test. Measure 20.172. The measurement from the vernier caliper is 20.15. The reading is 20.172. So it's only 22 microns from my vernier caliper. Okay, next the Sermoon S1. Sermoon S1 has the single line laser, so I will use it in combination with the 7 lines. The opening is only 9mm and it's go 32mm deep. So the Sermoon S1 can go only twice the width of the hole, so it will not reach the bottom of this hole. But let's see if it can scan the pockets here. Point cloud 0.15 parallel lines. So S1 will scan faster than the Laptors because it's run at 9 frames per second. So it can capture the surface quicker. Leaning angle is the same as a Laptor, so it can scan the side wall very well. So I'm going to switch to single line. So I can use a single line to erase the deep pocket area. So you can see it's quite slow to capture, but it can capture well. The bottom of the hole is quite deep. I don't think it can reach it because I can see it from the previous screen that I think if the hole depth is somewhere about 20mm, I think it can reach the bottom, but this one is 32, it's too much. Okay, you can use it to erase the blind spot. Okay, let's flip it over. This one has a lot of pocket. Okay, switching to a single line so you can capture. Okay, so you still have 40,000 frames frame limit. So you need to be quick, and a single line is scanned quite slow. Okay, it has only one line. If you want to less all of the blind spot, let me lower the desk. And so if the desk is too tall, you're going to have a shoulder pain when you scan this. It's quite glossy inside the pocket, so at some corner it won't be captured. Okay, I will fuse it. 0.15 aligned. It's not aligned automatically. I need to do it manually. Okay, let's match 2.1, 2.2. Okay, this is the mesh result from the S1. I think it's more complete than the Laptor's, especially the bottom of the pocket. So actually you can see the bottom of the hole from this side. I'm going to move it about here. The point cloud thickness from the S1 is thinner than the Laptor's. 20.118. 20.15 minus 20.118. So it's about 32 microns from my vernier calipers. Okay, next Revopoint Metro X. I will scan it using 7-line parallel line laser. I'm going to use 0.15 for the resolution, scanning parallel lines and black object. Using automatic exposure, I need 0.15 for part this small. Let me lower the table. This is the optimum distance for the Metro X. I need to scan the side, so I will lean. Okay, I need to be very far to be able to lean it. This is captured much slower than the Laptor's. And you can notice that it won't capture the markers at the end of the turntable. It's quite difficult to scan the sides. I'll flip it over here. Some part of the sidewall, it won't turn to green color. Okay, next I'm going to fuse it one by one. High quality 0.15. Okay, here's the first scan. Okay, this should be good enough for merging. Generate model, and this is the generate model. Mesh it with the 0.15 millimeter high quality mesh. Apply. Okay, here's a mesh result from the Metro X. 1 millimeter. The cross-section point cloud is not complete, and there are noise and missing information. Let's check the accuracy from this point to this point. 20.014, 20.15 minus 20.014. So it's give 136 micron error. Creality scan Otter, the infrared scanner. Okay, first I'm going to show you scanning with a marker. I will use a small object mode. This will give a higher resolution. For the Otter, it can go up to 0.15 millimeter in the small mode. And I'll track with the marker first, just to show you the difference between the marker and the geometry tracking. You can see that in the preview screen, I choose the automatic exposure and the screen is burned out. This is because you can have only one exposure. Actually, they have two tabs here, but it's only one that actually works. So if you bump up the brightness to scan the black object, it will burn out the markers. The marker will be invisible, so it will be more difficult to track, especially on the side here. If I choose automatic, only few of the surface area we capture, so I need to use the manual and bump up the brightness to 790. And when I start to scan, you see that it's quite hard to track because the marker is burned out. So if you lean it to the side, it will lose tracking because it cannot lean that much as the Laptor. Okay, I'm gonna fuse it to 0.15. The scan with the Otter is give a very rough surface from the overexposure because it has to be able to see both the markers and the black surface, and one side of the surface here is not captured at all. You can see here. So it's incomplete scan with the Otter in the marker mode. So if you want to scan with the Otter in the marker mode, you need to use a spray to reduce the contrast between the color of the object and the color of the marker, which is white color. Or alternatively, if you don't want to use the spray, want to scan the black object, you can use the geometry mode to track and use the small keep here to add the feature to the scanning scene, and it will track better. Okay, make a new scan, small object, geometry mode, and I will turn on exclude flat base. So when you scan on a turntable, I recommend that you turn on the exclude flat base. It will track better. It will focus on the object that is above the turntable. When you are scanning in a geometry mode, the automatic exposure works very well with the Otter. We start the scan. And you can also lean to the side because it doesn't have to track with the markers. So you can lean with a very low angle. So here it can capture all the walls if you track this object using the geometry mode. And you can notice the speed. The speed in the geometry tracking is faster than the marker tracking. So I have a 30 FPS versus 20. It's tracked better than the marker for the black object. But if this object is white color, you won't see any difference between the marker mode and geometry mode. Something wrong with my button here, the touch sensitive button. On my Otter, it doesn't work very well. Move to the second scan. Okay, I will start. The preview screen for the Otter doesn't show you a lot of detail, and maybe you can see that it can go into the deep pocket. I think it's better than the Laptor, but the sidewall is captured quite well inside of the pocket. And then I'm going to fuse both of the scans. I use 0.15. This is the best resolution that the Otter in a small mode can do. When you use the exclude flat base, the turntable will be removed automatically after fusing. So you need to fuse it first, then you can start cleaning it. Okay, let's check the scan quality between the geometry mode and the marker mode. This is what I'm trying to tell you. This is a scan from the marker mode. You see it's all burned out with the overexposure and incomplete scan. But if you use geometry mode, it's totally different. This is the same scanner. So you need to choose the mode correctly. Otherwise you are going to end up like this. Let's merge these two scans together. Okay, so it can merge. Next I'm going to mesh it. Okay, this is the result from the Otter. Let's check the accuracy. 20.167, 20.15 minus 20.167. Surprisingly, it's only 17 microns earlier. Okay, next the Otter lite infrared scanner. I use small mode and geometry tracking, exclude a flat base. The Otter lite is the same as the Otter. It's better to track in the geometry mode. So when you use the geometry mode, you can scan the side of the object very well. If you use the marker, you're not going to be able to get the same speed as the Otter. The tracking is not as good as the Otter. So I'm going to fuse it. Let's try 0.15, but I think the lowest resolution that the Otter lite can do in a small mode is 0.2. Okay, so all the table is removed after fusing. 2.5. You can see here that the embossed text doesn't look sharp and blur. I think it's the resolution is somewhere 0.2 or above. 20.17. So accuracy for the Otter and Otter lite is very good. The Ferret, let's see if it can scan this. I think it's too small for the Ferret. It's good for the object about the size of the shoes. So let's see if it can capture the lips and small intricate detail. Small mode. Geometry, exclude flat base. The walking distance for the Ferret is further than Otter lite and the Otter. So when the camera is away from the surface, it's going to see less of the resolution. Ferret has no button, so you need to use the keyboard to initiate the scan. Let's see if I can scan the side. It's not capturing much of the surface. If I lean to the side, I can capture the side walls. It shows right here 30 frames per second. New scans. I'm going to flip this. The camera is very far away from the scanning surface. I can tell you, it's not going to give you a very good resolution. I just noticed that the RGB camera from Ferret is very good quality. Yeah, 0.15 will be the lowest resolution. I can do this 0.2, I think. It's not going to get any better than 0.2. It's totally incomplete scan. I think it's here, 1, and mesh it, 1 million. Okay, let's check the dimension from the Ferret. Okay, at least it has the wall. 19.88, 20.15 minus 10.88. That's 0.27 millimeters. That's too much. Okay, next, the 3D Maker Pro Seals a 3D scanner. This one has a higher resolution than the most. Its tracking is the same. This one has 0.15 millimeter, a maximum resolution, and the most is 0.2. So this should give a better resolution and detail than the most. And I'm going to use the geometry mode. And no color. You have to adjust the brightness manually, but it's not difficult because the previous screen it shows more information than the previous screen of the infrared scanner from the Creality. The seal has no button, so you need to use the keyboard to operate the scanner. Even though it's run at 11 frames per second, but it tracks very well. The tracking performance is good. The moose track better than the seal. It has a larger capture range. Okay, I think that's about it. Okay, let's move to the other side of the scan. Yeah, I scanned the sidewall very well. Maybe I haven't mentioned this, but the seal has no marker mode. Seal and the mouse. So it's rely on the geometry tracking only. Let's align this. Okay, so the automatic alignment works. And next I'm going to process the point cloud. I use advanced mode and use the 0.15mm resolution for the seal. Okay, here's the mesh result from the seal. And there's some noise that has not been removed here. I'm going to do a thin cross section. Yeah, 20.2, 20.201 minus 20.15. This is the last one, meta-inform 3. This new firmware update from the meta-inform, you can adjust the projector brightness, so it scans the black color much better. It has an autofocus camera, so I'll use the scan density in the medium, because if I use it high, the processing time will be very long. So you need to calibrate. Going to add the second scan and start the scan. I think I'm gonna need a third scan. Put it like this. Okay, so I need to make a third scan here. Fourth scan, add. So we must scan 3 and 4 together first. Okay, now 3 and 4 is merged. I'm going to create a group and put 3 and 4 into the same group, and next I'm going to merge 1 and 2 to the group 1. Okay, 1 is merged, so I'm going to move 1 into the group, and then I'm going to merge 2 into the group. Some part of the wall is not scanned. Okay, let's merge the scanned. So I'm gonna choose the medium quality mesh. Okay, for the meshing, it doesn't take long. The quality is quite alright. I'm going to slice it. Going to measure dimension 20.24. Okay, so 20.15 minus 20.24, so 90 microns. Okay, let's compare the result in the render scene. The ray tracing. On the far left, we have Laptor, S1, Metro X, Otter, Otter Lite, Ferret, Seal, and MAF3. And the number behind the name is the accuracy error. So the lower is the better for me. If the accuracy error is under 50 micron, when you machine the part with the CNC milling or FDM printer or resin printer, the part that produced with the 3D scan data will fit. So in this test, the lowest accurate 3D scanner will be the Ferret. And you can see that it gives distort shape. Ferret is not made for this. It doesn't even come with a calibration board. and the part that we scan is too small for the Ferret. Blue laser scanner, Laptor S1 and the Metro X. The Metro X give quite a unique low accuracy of 136 micron. This is aligned with my previous tests when I scanned the aluminum block. And when you make a closer look here for the resolution, if you look at the embossed text, the Laptor will give a better, higher resolution than the S1, just a little bit. But if you look at this end here, the end of the pocket, the S1 has a single line, so it can capture this corner better than the Laptor. So the Laptor keeps some noise here. This is the noise from uncaptured data, and the S1 capture it all. So it has a little bit lower resolution, but the completeness of the scan is different. And if you compare this with the Metro X, okay, so you can see that the Metro X has a lot of noise in the whole area and also in the pocket here. So when you need to find the location of the hole, this could cause a problem. If you look at the resolution of the scan from the embossed text, the Metro X has a lower resolution than the S1 and the Laptor. Even though it's fused with the same 0.15 millimeter, I spent the longest time scanning with the Metro X. It takes the longest time to scan. The Metro X lost some of the data, so it's incomplete, while the S1 and the Laptor give more complete on the lips here. The Laptor is here. S1 and the Metro X. The S1 give the most complete scanned in the pocket. The Laptor 7 line couldn't capture a lot of surface inside of the pocket, so this area is totally uncaptured, while the Sermoon S1 with the single line can capture the bottom of the pocket. You can notice the noise here along the edges of the scan. There's a lot of noise. Comparing with this corner from the S1 and the Laptor, it's more clean and sharp. Okay, let's move to the infrared, the Otter. Okay, I can say that the Otter does very well in this test. Black object, when you look at the Otter lite or the Ferret, is totally different. It can scan black object without the spray very well, much better than the Otter lite, and it gives more complete scan than the Otter lite. If you look from here, it's even better than the Metro X. It has a lesser noise. It's not as sharp as the Metro X, but the surface quality is good. And when you look at the precision error, it's only 17 micron in this test. The Otter lite resolution is too low for reverse engineering work. See, it's incomplete and it gives a very low resolution. Okay, the Otter, some of the sidewall is scanned, some of the ribs here is scanned. The completeness of the lips is okay, but it's not as good as the laser scanner, but it's more complete than the Metro X. And there's a boundary noise that you can remove, but when you fuse the Otter, you need to slide the noise removal 100%. Surface quality is good, quite smooth comparing with the Otter lite. So I can't recommend Otter lite for reversing the small part. It's going to give you low detail. The sidewall here is all missing. And for the Ferret, it's totally failed to scan this. Okay, the seal give a good accuracy error, 51 micron. It give quite a lot of noise here. I don't know why. Tracking performance is okay, better than Otter lite, but not as good as the Otter. For the resolution, I would say it's quite close to the Otter, but the surface is not as smooth as the Otter, because with scanning the black object, I crank up the exposure, so it gives a rough surface. But it's still smoother than the Otter lite, and the precision is quite okay. Deep pocket scan is okay. It cannot reach the bottom of the pocket. The edge of the hole is quite clear. The lip scanning is incomplete. Comparing with the the Otter Dust Bear math tree. Solution is comparable to the seal 0.15. I didn't use the highest resolution from the math tree because it's going to take a very long time to process, and some part of a very thin wall is not captured like this one. But they have improved a lot from the past for scanning the black object. Okay, so here's my thought on the egg scanner test today. Took a fairly long time to do this, so I hope that it will give you some information of which scanner to choose from. Thanks you guys for watching. See you in the next video.